Temperature and flow I am going to analyze here. Then again it's about the convergence, the flow how much it should be, and then what should be the energy. All these things we will be giving here. Then in each and every direction what is the velocity, initial velocity, how much it should be, like along z only as some gravitational, to consider some gravity we are considering 0.05 meters per second of gravity or velocity we are considering the particle which it drops. So for that we had considered only along z axis, and again radiation based on theta or the angular discretization, how it should be, those things we had included here. Okay, so these are the overall inputs, like what are the scenario which you are going to analyze your antenna, wherever the scenario it will be, all these scenarios you can give it here, and then just as usual it is, you can validate and analyze as it has been already analyzed. Okay. Here the material, it has changed actually in between as I changed. It has changed. So basically what we will be analyzing here is just we will see what is the mapping of, like how we see electric field distribution. The same way in that particular ring we will see what is the thermal mapping, how it is. So for the same once you go to this particular ring, once you go to right click on this, once you go to plot field, you can see an option temperature here. You can go for surface temperature or the overall volume temperature. Okay, so based on that you will be getting this particular temperature map here. The maximum temperature here is 43 degrees Celsius. So wherever it is high, if you want to see, you can zoom in and map your temperature here. So other than that, you have some heat sinks, all these for thermal management here. For example, if you want to reduce any kind of heat here, heat sinking devices it is, which is already present in market, that library files will be there. You can just take it and you can place it as a heat sink here. So this was about thermal management. Let us start with metamaterial concept or the unit cell analysis concept. For this I will start a fresh design. So basically unit cell analysis, as I explained you already, I'll just give you a short glimpse what we do in unit cell analysis. So most of you had used VNA, I think.
VNA.
So most of you had used VNA. So VNA is a kind of an material characterizer. Okay. So what we'll do is, in VNA you will be having, like in VNA there will be cables coming out of it. Like in that only we will be connecting our antenna or whatever the filter analysis. So basically, if you don't connect anything here, if you keep any kind of material here, based on the reflection coefficient, it will characterize the material characteristics.
How do you connect it?
In that particular end, there is another port or let's suppose a probe kind of thing will be there. So initially VNA was constructed basically for material characterization.
Starting.
Initial cases in 50s and all, 1950s and all, the